Hi guys, welcome to Feynman Scholar. In this video we will go through some questions based on the principle of superposition of charge, and hopefully I will cover 4 types of questions seen mainly in the paper. And I hope you like the video, comment in the comment section, and please subscribe to my YouTube channel and hit the bell icon. So let us begin. So in questions which are related to the principle of superposition, we mainly need two things, that is the Coulomb's law. Coulomb's law is force is equal to K capital Q times small q divided by R square. Here capital Q is one charge and small q is one charge, and R square is the distance square between them. And we also need the vector addition formula, that is R is equal to under root of A square plus B square plus 2AB cos theta. Here R is the resultant, A is the first vector which we are considering, B is the second vector. So in the first question what they are telling is we need to find the net force on the charge which is placed at the vertex at C of an equilateral triangle ABC. So they have taken an equilateral triangle ABC where at the edges or at the vertex three charges are kept, and the magnitude of these charges are same, that is plus q plus q plus q. Also they are telling us that this triangle is an equilateral triangle, that is the sides are all same and the angle between them is also same. So they have given us that one side is A. So since it is an equilateral triangle, all the sides will be A, and they have not given us the angle between them, but they have given us that it is an equilateral triangle, so therefore the angle must be 60 degree on each three of the sides. So now they are telling us to find the net force at this point C. So first of all let us consider the force on C due to A. So force on C due to A is along this direction, that is in this direction. So we name this as force on C due to A, and force on C due to B is in this direction, that is we name it force on C due to B. So we consider this whole vector outside, we take its free body diagram, and we take these two vectors, that is force on C due to B and force on C due to A here, and we see that here the angle is also equal to 60. This is because these are vertically opposite angles, so vertically opposite angles are same. Since here it was 60, therefore angle between these two vectors will also be 60 degree. So we get that angle is 60 degree. So now we have only two forces over here, that is force on C due to B and force on C due to A. So we know that over here force on C due to A, we can get that from Coulomb's law, that is K Q Q by A square. Here Q and Q are the charges. Since here all the charges are same, so we take as Q only. Otherwise if they were different we can take a different charge over here, but since they are same we are writing it as KQ by A square. Here the distance between any two charge is given to be A, as it is the side of the triangle, so we get the distance between them is A square. Also force on C due to B is equal to KQ by A square. Since force on C due to A is equal to force on C due to B, these two are equal, therefore we take them as F only. So the net force we'll get by this formula, that is resultant, or we'll vector sum it, then we'll get force net is equal to F square. Over here we have taken this F as the first vector, so we get F square plus the second vector is also F, so we took F square plus here 2AB, so in A is also F and B is also F, so we get 2FF and at last cos theta. So here cos and the angle between these two vectors is 60 degree, so we take cos 60. So cos 60 is 1 by 2. So we add these two and we get that force net is equal to under root of 2F square plus 2F square multiplied by cos 60, that is 1 by 2. So 2 and 2 will get cancelled and we will be left with f square plus 2f square. So force net is equal to under root of 2f square plus f square, and we get force net is equal to 3f square. Since here f square is there, we can take it out as f, and we get force net is equal to f under root 3. So now here we know that F is equal to KQQ by A square. Therefore the force net becomes KQQ by A square multiplied by this root 3. So we'll write over here also root 3. So the total force on C is equal to root 3 multiplied by KQ square. Here this two Q's were there, so we'll multiply them and we get Q square divided by A square. So this is our final answer. So most of the time we solve the question like this only, that is we get the direction of the force and we get the angle between them, and then we vector add them and we get the final answer. But most of the time a question can be solved a bit mentally also, when if we could understand, like in this second question. In the second question we have been told that there are 4 charges which are kept at the edges of a square, and in center there is one charge of 1 microcoulomb kept at let us assume the center is O, so at that place it is kept, and the distance between two charges or the side of the square is 10 centimeter, and we have given 4 charges. So let us take this square to be A, B, C, D. So at A there is plus 2 microcoulomb of charge, at B there is minus 5 microcoulomb, at C there is plus 2 microcoulomb, and at D there is minus 5 microcoulomb. Most of the time we go for solving these types of question, but we can mentally solve it like we see here. So if at this center O 1 microcoulomb charge is kept, so A, since it is positive and plus 1 microcoulomb is also positive, that's why from A there will be a repulsion in this direction, and from C also, since it is plus 2 microcoulomb, there will be a repulsion in this direction. These two repulsions are in opposite direction. Also the magnitude of the charge at A and C are similar, therefore equal and opposite, they might cancel each other. So we see that this force is cancelled. Now we are left with these two. So over here we see that in B minus 5 microcoulomb charge is there, and in D minus 5 microcoulomb charge is there. So again here the magnitude is same. Now let's see the direction. Since at center O there is a positive charge, that is 1 microcoulomb, and B is a negative charge, so there might be an attraction. So since B is negative, so it will attract it towards itself, so the direction is over here, and D also it will attract it towards itself. So in this case also the direction is equal and opposite, also the magnitudes are same, therefore this force is also cancelled and this force is also cancelled. So we see that net force in this system is 0. So hence we can come to a conclusion without even solving, that the net force on the charge at the center is 0. There is one thing that you can note from here, that whenever there is symmetrical distribution of charge, then the net force on the charge is in the center is 0. Like in this case only we see that there is symmetrical distribution and the charge is at center, therefore the net charge on that point or at the center will be equal to 0. Also we can take a problem like this, that there is a square and in middle one charge is there and all these sides are having same magnitude of charges, then also the net force on this charge will be equal to 0 only. So the force net will be equal to 0. Now let us see the third question. So the third question is similar to the first question, instead of all positive charges. So in this case also we see that a triangle is taken, an equilateral triangle. In that triangle 3 charges are kept. At A there is minus q charge, at B there is plus q, and at C there is plus q. So, and the distance between all the charges is a, that is the side of this equilateral triangle is a, and the angle between them will be 60 degree because it's an equilateral triangle. So in this case, since a charge is present at a, so we need to find the net force on that. So we see that the charge is negative, therefore there will be an attraction by the plus q charge over here, so it attracts it in this direction, and similarly C will also attract it in this direction. So we see that it attracts like this. Now we take a free body diagram of this and we get this thing. So over here this vector is force on A due to B, and this vector is force on A due to C. So similar process only, we will do the same thing. Here we see that force on A is equal to KQQ by A square is equal to F. Here the one thing to notice is that we have not taken the negative sign of the charge. That is, when we are solving questions, we might have to ignore this negative sign, because this negative sign only gives the direction of the force. Therefore we are neglecting it, or we are not considering the negative sign. Therefore we get KQQ by A square, and force on A due to C is equal to KQQ by A square. Since these two again are similar, we get force. This force we can take as F, and this also we can take as F, and we'll do the similar process as we did in the first question, that is F net is equal to these two, sum of these two forces multiplied by the 2AB cos theta. We'll get the same thing, that force net is equal to force times root 3, and we'll get the same answer also, that force on A is equal to root 3 KQ square by A square. So now let us come to the fourth question. So in the fourth question we are told to find the net force on a charge Q which is placed at the center of this square. So let us begin. So here we have taken a square ABCD. In that there is at the center O there is a charge Q, and we are told to find that what is the net force on this. Over here we have we see that there are three similar charges and one different charge. So at A there is plus Q charge, at B there is plus Q, and C there is minus Q, and at D there is plus Q. And we see that here the distance between the two charges is A, and the side of the square is also A. So we get that all the sides must be equal to A. So we get the free body diagram of how the forces are. So here we see that due to A, the force will be opposing this charge. Since the charge is plus Q, so there might be a repulsion between these two charges, that is, it will oppose it in this direction. Or from B to O, there will also be a repulsion from this direction. So we get that the force will be in this direction, that is, it will be coming like this. This will be force on O due to B. From C, since it is negatively charged, there will be an attraction to this plus Q charge, so the direction of that force will be towards itself and not away from it. On D there is plus Q charge, so it will apply force in the away from it. That means it will try to push this charge at the center away from it, so the direction will be in this side. So here we see that B and D, they have the same charge, that is magnitude is same, and they are in equal and opposite direction. Therefore these two charges are cancelled, and now we are left with this system of charge, that is force on O due to A and force on C. So let's see how to do it. So we see that over here A to C, that is the diagonal, and B to D is also a diagonal. Now if we want to get the distance, so we need to find this distance right over here. We need to get what is the distance from here to here. So to do that, we'll consider this whole as a diagonal. Since it is a diagonal, Therefore we can divide this diagonal and get only this much part. That means from this full diagonal we will get part only till here. So a diagonal has a length of a root 2, or in this case, otherwise it will be the total distance times root 2. So we see that over here we need only half the distance, therefore we'll divide it by 2. So we get that here a root 2 divided by 2 is given. 2 we can write it as root 2 times root 2. Then we can cancel this, that is 1 root 2 and 1 root 2 we can cancel, and we are left with a root 2. So now we'll do the same thing. Now we'll consider the force on O due to A, which is equal to KQQ by A square and multiplied by 2. In this case, because over here the distance is A by root 2, we got over here, that is the distance. So we'll square them. After squaring we get that A square. This a by root 2, it becomes a square, and since we are squaring this root 2, we get only 2 as the answer, but 2 will go on in the denominator because a by root 2 is already in the denominator. Therefore 2 will go in the numerator, and we get force on O due to A is equal to 2kqq by A square. Force on O due to C we'll get by same way. We see that we get 2kqq by A square. Now these two again, this FOA and this FOC, both are similar again, so we'll consider them as F only. So again we will do the same thing, that is we will add them by vector addition. So we take R is equal to F square. So F square over here represents A square, plus F square over here is this one, it represents B square, and 2F square represents 2AB, and cos 0 is cos theta. Here we got cos 0 because we see that these two, this one, this one, these are in same direction, so we can consider them as parallel vectors. So the angle between two parallel vectors is 0 degree, therefore we got cos 0. So cos 0 is 1, so we are left with 2F square again. So force net is equal to under root of 2F square plus 2F square. So we can add these two F squares and we get 4F square. So force net is equal to under root of 4F square. So now we'll take it out of root. So we get 4 will become 2 and F square will become F. So we get force net is equal to 2F, but we know the value of F is 2kqq by A square. So we get the force on O, the net force on O is equal to 2 times that of the force, that is kqq2 by A square. So 2 and 2 we can multiply and we get 4. This 2 q's also we can get q square. So total answer, that is total force on O, is equal to 4kq square by A square. So now let us revise the key points that we learned from this question. So whenever we are given this polygon types of questions, so in that we have to find out the two vector force or the two vector quantities, or maybe even more vector quantities, and we must try to find out, or we must try to cancel them if possible, and then we must add them by vector addition. And we must remember this formula, that R is equal to under root of A square plus B square plus 2AB cos theta. Also we must know the Coulomb's law, and with that we can get the answer of the net force on a particular side or particular edge or whatever is given in the question. Also we saw that whenever there is symmetrical distribution of charge, like we saw in the second question, which is also from the NCERT exercise 1.6, we saw that if there is a symmetrical distribution of charge, then the net force on that charge which is at the center will be equal to 0. Also we saw that if the charge is negative, then this negative will attract towards the positive one, so there is change in direction. We must keep in mind that also. And the remaining procedures are similar, and we get that whenever a square is given in that there is asymmetry is there, then we must try to cancel out which are given by symmetry, or equal and opposite ones we can cancel them out, and the one which are in same direction we can use the same thing again. Also we must remember that the diagonal of a square is given by, or the length of the diagonal is given by a root 2, and since we only need till center, we can divide that by 2 and get a by root 2, and the remaining procedures are again similar. So hope you like the video. Please comment down in the comment section, and please subscribe to my channel, and thank you for 50 subscribers. Thank you so much.